In this video, we're going to be taking a look at evaluating expressions, and you'll need to get out your math book and turn to page 269 and get out your math journal and a pencil. So let's take a look at the essential question. It is, how can you use the order of operations to evaluate algebraic expressions? So let's take a look at evaluating expressions. It says, recall that an algebraic expression contains one or more variables. You can substitute a number for that variable and then find the value of the expression. So we're going to take it one step further. We're going to have a number that the variable represents. This is called evaluating the expression. So let's take a look at letter A. In example 1, it says evaluate the expression for the given value of the variable. So it says x minus 9. And they tell us now how much x is worth. So x equals 15. So then we replace the variable with the number 15. The reason for that, because they're telling us x equals 15. X does not always equal 15 though. So a variable can represent any type of number. So 15 minus 9 equals 6 for the answer. So that's what's called evaluating the expression. So let's take a look at letter B. We have 16 divided by n, and then the variable n equals 16. So what we can do here is we take the variable, replace it with 8. N equals 8. So we have 16 divided by 8 now, and then we divide, which will give us 2. So when n equals 8, 16 divided by n equals 2. Now let's take a look at letter C. We have 5/10 multiplied by y, and then y equals 1 4/10. So you take 5/10, and then you can even put 1 4/10 in parentheses. And then now we can substitute 1 4/10 for the y, because that's what it's substituted for. Then you multiply 5/10 times 1 4/10 is going to give us 7/10. So therefore we can see when y equals 1.4, or 1 4/10, 5/10 times y equals 7/10. Now let's take a look at letter D. 6 times k, and then k equals 1/3. So it's important to think, or a hint, think of 6 as 6 over 1. And then we can multiply 6 times 1/3, and then you have 2. So when k equals 1/3, 6 times k equals 2. So those are some examples of evaluating expressions. So let's do some together now. So for number 1, we have 4 times x. Now x equals 8. So we can set this up. 4 times, so the x equals 8 now. Replace that variable with an 8. So 4 multiplied by 8, pretty simple, giving us 32. Let's take a look at number 2. 6 5/10 minus n. Now n equals 1 8/10. So we have 6 5/10 minus n, knowing n equals 1 8/10. So we have 6 5/10 minus 1 8/10. Why do we know that n equals 1 8/10? Because they tell us. And we subtract. 15 minus 8 is 7. I drop down my decimal. 5 minus 1 is 4. 4 7/10 for my answer. Now let's take a look at number 3. We have m divided by 6, and then m equals 18. So we can replace that m with 18. So let's do that. Now we have 18 divided by 6. And that will give us 3 for the answer. So you can write 3 for number 3. Now let's take a look at using the order of operations. If you remember, please excuse my dear Aunt Sally, is the order of operations representing parentheses, exponents, multiplication or division, whichever one comes first from left to right, or addition and subtraction, whichever one comes first from left to right. It says expressions may have more than one operation or more than one variable. To evaluate these expressions, substitute the given value for each variable and then use the order of operations. Now I'd like you to take a look at example 2. Letter A, B, C, and D. You can look over and see how, or the different steps for these types of problems. And let's take a look at doing number 4. We'll look at that together. So we have 3, and let's write this out together, 3 times n plus 1. Now we know the value for n is 5, so we'll rewrite, plugging in the number for the variable. Now we think through the different steps or the order of operations. Please excuse my dear Aunt Sally. Now we can, first of all, do parentheses. 5 plus 1 will give us 6. And then whenever there's a parentheses next to a number, it's always understood to be multiplication. So now we can multiply for our next step. 3 times 6 will give us 18. You can write 18 there for number 4. Now let's take a look at, number 4. Let's take a look at number 6. Okay, so let's write it out first of all. 6 times n plus n squared. Okay, so taking a look at this, the first thing we need to do is plug in 5 for the variables. Why do we plug in 5? Because it says right here n equals 5. So we have now 6 times 5, which is the n, plus 5 to the power of 2, or 5 squared. Now, what we need to do is take a look at our order of operations. We don't have any parentheses here, so we go right away to the exponents. 5 to the power of 2 will give us 25. We can drop the other numbers. 6 times 5 plus 25. Now we need to think through the order of operations. We have multiplication and addition. We know, multiplication comes before addition. So we can multiply 6 times 5, giving us 30. And drop down the addition symbol and 25. And now we have 30 plus 25 will give us 55. So even though we're taking a look at algebraic expressions, the order of operations still does apply. So let's take a look at number 7. So it says evaluated expression a equals 3, b equals 4, c equals 6. So if we have an expression, let's write this out. A times b minus c. First thing we need to do is plug in the numbers for the variables. So a, we know, is 3, times b, which is 4, minus 6. Now that we've replaced all variables with numbers, we can solve the problem, or we can evaluate the expression. First of all, multiplication comes first. 3 times 4 will give us 12. Drop down the subtraction sign, minus 6. And then now we have 12 minus 6 for 7 equals 6. Now let's take a look at number 9. We have a to the power of 3 minus b plus c. So first of all, we need to plug in the numbers for the variables. So now we have 3 to the power of 3 minus 4 plus 6. Now, first of all, we will do the parentheses in the order of operations, which is 4 plus 6, and that will give us 10. Drop down the subtraction problem, drop down the 3 cubed. Now we can multiply 3 times 3 times 3, and that's going to give us 27. We do that first because exponents comes before subtraction. So we have 27 minus 10. and that will give us the answer of 17. You can write 17 in there for number 9. So let's take a look at evaluating real-world expressions. It says you can evaluate expressions to solve real-world problems. So it says the expression 1 8/10 times C plus 32 gives the temperature in degrees Fahrenheit for the given temperature in degrees Celsius. So find the temperature in degrees Fahrenheit that is equivalent to 30 degrees Celsius. So step 1, we need to find the value of C. Okay, so we found the value of C because it says the degrees Fahrenheit that's equivalent to 30 degrees Celsius. So C equals 30 degrees Celsius. And then from there we can substitute the value into the expression. 1.8 or 1 8/10 times 30 plus 32. So we need to multiply 1 8/10 times 30, giving us 54, plus 32. So we have 32 here. And then we add it together, which is 86. So 86 degrees Fahrenheit is equivalent to 30 degrees Celsius. Let's take a look at number 10. So it says the expression 6 times x squared gives the surface area of a cube, and the expression x cubed gives the volume of a cube, where x is the length of one side of the cube. Now we want to find the surface area and the volume of a cube with a side length of 2 meters. So we can see that x will equal 2. So we can write our expression x times 2 squared for the first one. You can see now as far as the surface area, so 6 times 2 squared. First of all, we'll do the exponents. 2 squared is 4. We can drop down our 6, drop down our multiplication sign. Now we have 6 times 4 equals 24 for the surface area. Now let's take a look at the volume. Now we know the volume, the expression x cubed gives the volume of a cube. Now we already know that the side has a length of 2 meters. So x cubed, the x will equal 2. Now we have 2 cubed, or 2 times 2 times 2 is going to give us 8 for the volume. Okay, let's take a look at number 11 together. It says the expression 60m gives the number of seconds in m minutes. How many seconds are there in 7 minutes? Now, so we know that the algebraic expression is 60 times n, and they're asking how many seconds are there in 7 minutes. So we know that 60 represents the seconds, and the m variable represents the minutes. So we have 60 times 7 now for a multiplication problem. So we know 60 times 7 gives us 420. So when taking a look at evaluating real-world expressions, it's important to think about what the constant is. So the constant for number 11 would be the 60 seconds. And the variable would represent the letter m. We don't know how many minutes they're talking about, but we can see within this problem, the 7 represents how many minutes that the problem was focusing on. So let's take a look at page 272. This is the guided practice. And I would like you to work on number 1, and you can work on that now. So number 1, we have 16 for the answer. Now I would like you to jump down, and I want you to work on number 6, and you can work on that now. So number 6 is 50 for the answer. I want you to take a look at number 7, read through that problem, complete letters A and B, and you can work on that now. So you can see, first of all, for letter A, 12 times x plus 5 would be the expression that you can write. And then you can see 12 times 3 plus 5 equals 36 plus 5 will equal 41. Sorry, 12 times 3 gives us 36, and then plus the 5 gave us 41. So we can see that the family spent $41 to attend the game. Now let's take a look at the essential question check-in. It says, how do you know the correct order in which to evaluate algebraic expressions? We substitute the variables and follow the order of operations that you would use for a numerical expression. And this wraps up the video on evaluating expressions. If you have any questions about this concept, please come and see me.